In this video, we're going to learn about periodic functions. So periodic functions are functions that have a repeating pattern. So here at the top it says periodic functions are functions that have a repeating pattern. Now there are lots of types of periodic functions in the world. Wallpaper borders, those have a repeating pattern. I've got a couple of here that we're going to take a look at. So the first one here is an EKG or an ECG, which stands for an electrocardiogram. And what that does is it measures your heart rate. And if you take a look at it, it definitely has a repeating pattern. It has a peak, and then it has a couple of little smaller ones, and then a peak, and then a couple of little bit of smaller ones. So this is a function that I would definitely say is periodic because it has a repeating pattern. Now an ECG or an EKG that is not normal, so here we've got ventricular fibrillation. That would be when your heart rate's just racing like crazy. So it's got an irregular beat, it's just beating like crazy. It's not the nice steady rhythm that your heart is here. This one here would be not periodic because I do not see a pattern there. So with your heart, you'd like it to have a nice steady periodic rhythm because it's going to be beating at regular intervals, and when it's not periodic, that's not really a good thing. Now the next one down here we're looking at is an EEG. So an EEG stands for an electroencephalograph, and an electroencephalograph measures your brain waves. So this is what a normal EEG looks like. You'll notice it just has all sorts of peaks and valleys all over the place, and that there really isn't one clear pattern there. So I'd say that this is not periodic. That's normal because your brain is controlling so many different things at the same time. It's reminding your heart to beat and your lungs to breathe, and you're thinking about what you're having for lunch tomorrow and what someone just said to you 5 minutes ago. So you have a lot of electrical impulses going on in your brain, and you really shouldn't see a pattern there. Now, this is an EEG of someone who has comatose anoxic encephalopathy, which means that they have brain damage. And you'll notice if you take a look at this one, I know that there's a lot more, but if I take a look at just, say, the top one, that here there definitely is a clear repeating pattern, which when it comes to your brain is not a good thing. So I would say that at the end it loses its periodicity, but this is, in the beginning parts anyways, periodic. So when it comes to your brain, not periodic is good and periodic is not very good. Also, people who have mad cow disease, and they've got brain damage because of mad cow disease, or people who have Alzheimer's and dementia, they will get very similar brain patterns when it's in its advanced stages. So I have two more examples here. This one here is a seismograph. A seismograph measures earthquakes. So when I take a look at this one, it builds, and then there's some big jagged ones, and then it kind of goes back down. So I would say this is not periodic. And that's not the way an earthquake works. So in an earthquake, you get shaking, and it gets gradually worse, and then it lessens off. It's not like you get a shake, and then a shake, and then a shake. If it just continued on like that, it would drive you crazy. All right, and our last one here is a music note played on a harmonica, and you'll notice if you take a look at the wave that I get here, it is definitely a repeating pattern, so I would say that this is periodic. So, periodic functions have a repeating pattern, not periodic functions do not have a repeating pattern. You would like your heart rate to be periodic so that you have a nice even rhythm going. You do not want your brain to be periodic because then that would mean you have some type of damage. Okay, now there are some words that we're going to talk about in reference to these graphs. The first one is cycle, and then period, and then amplitude. And I think I'm just going to focus a little here. Okay, so a cycle is what we call one instance of the pattern that's being repeated in the function. So here I'm going to say it's one instance of the repeating pattern in the function. So if I were to go back and take a look at that very first one of the heart rate, Okay, one pattern here would be the big peak and then the little bumps that come after it. And then that repeats itself over and over and over again. So this on here would be one cycle, okay, of your heart rate. Okay, a period measures how long that one cycle is. Now this could be measured in time, it could be measured in centimeters or millimeters or inches. It just depends on what it is that we're looking at here. So on this one, okay, your heartbeat would have been measured over time, so your cycle would be how many seconds or milliseconds it would take for it to have the next beat. Now amplitude has to do with how high the function is, except it's not the full height of the function, it's actually just half the height of the function, which is weird. And eventually it'll make a little bit more sense to us, but for now we're just going to deal with the fact that it's half the height of the function. So if I was looking once again at that heart rhythm there, we would calculate our height, so probably measure it, and then the amplitude would be half of that. Okay, so the easiest way to calculate amplitude is you take the total height from top to bottom and you divide it by 2. Or we can use the formula max, so your maximum height, take away your minimum height, divided by 2. And in a second we'll actually take a look at how to use that. So we're going to do a couple of examples on the next part. We're going to take a look at some periodic functions. We're going to figure out their maximum value, minimum value, period, and amplitude. So whenever I'm doing one of these questions, the first thing I do is I like to highlight or trace over one cycle. So with a marker or a highlighter or even my pencil, just to color over top so that I know what one cycle looks like. Now if I take a look at this graph, there's lots of ways that I could see one cycle. So I'm going to do a couple of different examples of what one cycle might look like. One cycle could be going up and then coming down. You'll notice when we mark a cycle, the cycle should start and end at the same height or the same y value, right? So we go up, we come down, and then you'll notice that that gets repeated over and over and over again. So this is one particular cycle, but that's not the only way you could choose a cycle. Instead of going up and coming down, maybe you picked going down and coming up. Right? And then that gets repeated, so that it would also be considered to be one cycle. Or you could get fancy and maybe go from the halfway point and say we go halfway up, all the way down, and then back to halfway up again. So there's lots of different ways that you can mark on one cycle. You just need to figure out what you feel the pattern is that's being repeated. Now, regardless of which pattern we pick, whether we pick the pink one or the blue one or the green one, they all have, they're 4 squares long, and they're 1, 2, 3, 4, 5, 6, 7, 8, 9 squares high. So if I was taking a look at the maximum, we're going to assume that every square is 1 on here. So I get up to a maximum height of 9, so I'm going to say the maximum is 9. The minimum it is here on the axis, which would be 0. The period is 1, 2, 3, 4 squares. And then the amplitude is half the height. So to do the period, I like to do the maximum, which would be 9, take away the minimum, which is 4, and then we divide that number by 2. So 9 take away 4 is 5. So I could leave it as 5 divided by 2, or I could make it a decimal to get 2.5. Okay? So we're going to take a look at the next example. Same idea. We're going to start by highlighting what we feel one cycle is, and then state the maximum, the minimum, the period, and the amplitude. So I like to start at the maximum and then go until we get back to the maximum. So I would say maybe one cycle starts here and then finishes there, right? Because then that pattern is being repeated over and over again. So the maximum here is 1, 2, 3, 4, 5, 6. So it has a maximum of 6. And a minimum of 1, 2, 3, 4, 5, negative 6. Okay, the period is 1, 2, 3, 4, 5, 6, 7, 8. And the amplitude is half the height. So I'm going to do 6 take away -6, right? The maximum take away the minimum, divided by 2. So when I have a minus and a minus, that's really the same as doing plus. So I get 6 plus 6, which is 12, divided by 2. So 12 divided by 2 is 6. So my amplitude here would be 6. All right, so the next one, same idea. We want to start by finding one cycle of my pattern. I like to start at the highest point. It's up to you. So I'm going to start at the highest point. I'm going to go down, down, back up, and then I just check to make sure that that's actually being repeated, which it is. So my maximum height, the highest it goes, 1, 2, 3, 4, 5, 6, is 6 again. My minimum, 1, 2, 3, 4, ooh, is -4 this time. And the period, 1, 2, 3, 4, 5, 6, it's 6 units long. And then my amplitude, we can do maximum, take away minimum, or you could actually just count out the height. So I'm going to do 6, take away -4, divided by 2. 6 take away -4 is 10, divided by 2 gives me an answer of 5. All right, our last one here, I'd like you to try, and then at the start of the next video, we'll take that one up to see what you got.